You've deleted every reference, yet Python is still leaking memory. Why? Python's primary tool is reference counting. Objects are freed when their count hits 0. But if A references B and B references A, those counts never reach 0. Reference counting can't break cycles, so Python has a separate cyclic garbage collector. The cyclic GC doesn't track every object, only containers. Lists, dicts, tuples, sets, and class instances are tracked because they can hold references to other objects. Simple types like integers and strings are skipped. They can't form cycles. Here's how it works. Python copies each container's reference count into a temporary field, gzrefs. Then it walks all tracked objects and decrements gzrefs for every internal reference. After this pass, containers with gzrefs above 0 are reachable from outside. They're kept. Containers that hit 0 are only referenced from within a cycle and get collected as garbage. To keep this efficient, Python uses generational collection. Objects start in generation 0 and are collected most often. Survivors are promoted to generation 1, then generation 2. Collected least frequently. This works because most objects are short-lived. You can control collection via gc.collect, gc.disable, and gc.getThreshold. Python pairs reference counting with a cyclic collector that uses reference count simulation and generational sweeping to find and free unreachable cycles. That's the answer that impresses interviewers. Want to get better at answering questions like this? With Interview Mentor, you practice real interview questions out loud. You get personalized feedback and a grade on every answer, and you can track your improvement over time.